Hi, this is Mr. Estabrook, and I received a few questions about numbers 48 through 50 from the summer review packet, so I'm going to make this screencast to go over how to do these problems. The first thing we need to realize is that each of these problems is linear. There is no x squared or even square root of x. Now this x is multiplied by the square root of 7. Square root of 7 would be the coefficient, but the x itself is still to the first power. I can't use the quadratic formula because it's not a quadratic. There's nothing x squared. I don't want to square both sides because if I did that, I'd be multiplying this binomial by itself, and I'd end up with some more complicated terms in there, and I'd still have the problem of having some radicals in the problem. So instead, what we're going to do is look at the left side and factor it. We're going to factor the common term of x out of both of them, which would leave us with this. Now the good thing about this is the x is by itself. Now I only see x in one place. So what we'll do next then is divide both sides by 3 plus the square root of 7. And by doing that, on the left-hand side then, we're just left with x. On the right-hand side, we have 8 over 3 plus the square root of 7. Now that is an answer. We have x isolated all by itself. We know x is equal to this. The only problem is we have a square root down in the denominator, and that's not allowed. So what we're going to do next is multiply both sides by the same, both numerator and denominator, that is, by the same thing. I don't want to square numerator and denominator for two reasons. Number one, if I squared the numerator, I'd be multiplying the numerator by 8. If I squared the denominator, I'd be multiplying it by 3 plus root 7. Those aren't equal, and in a fraction, you have to multiply numerator and denominator by the same thing. The other problem with squaring the numerator and denominator is that even if I did square this, I wouldn't get rid of that radical sign. Instead, what we're going to do is we're going to multiply the numerator and denominator both by 3 minus the square root of 7. It's called the conjugate. Instead of 3 plus root 7, we have 3 minus root 7. We'll do the numerator first just because it will be a little bit simpler. 8 times 3 is 24. 8 times negative root 7 is negative 8 root 7. Okay, so there's our numerator. Looks a lot more confusing than what it was, but it is okay to have a square root up in the numerator. Now down in the denominator, we have to do the foiling. Multiply all the correct terms. 3 times 3 is 9. 3 times negative root 7 is negative 3 root 7. Root 7 times 3 is positive 3 root 7. And root 7 times negative root 7 is negative root 49, which then is just negative 7. So we multiply all those terms from the first binomial by the terms in the second binomial, we get all of this. And what's nice about this is these inside terms are opposites. So we're only left with 9 minus 7, which would give us a denominator of 2. One more step in this one. I noticed that all three of these terms, the 24, the 8 root 7, and the 2, are even, or in other words, their coefficients can be divided by 2. So if we divide them all by 2, we get x equals 12 minus 4 root 7 over 1. So we'll just leave it like that. 49. This time the x's are on opposite sides, so I'm going to move all of my x's to the same side. In other words, I'm going to subtract x root 5 from both sides, and also subtract 10 from both sides. Now the only place where we see x's is on the left. Like the previous problem, we're going to factor out that x, and then we're going to divide both sides by 4 minus root 5. So the process is the same in this case. We have just different numbers. Those simplify to give us just x on the left. So x is equal to negative 10 over 4 minus square root of 5. And again, this is an answer. X is by itself. However, I have a square root down in the denominator, so I'm going to multiply numerator and denominator by the same thing. In this case, it's 4 plus root 5. And I'm choosing to put this negative sign out front. We could leave it on top with the 10. I'm just choosing to put it on top. So x equals a negative of 10 times 4, that's 40. 10 times root 5, that's 10 root 5. And then down to the denominator, do all the distributing. 4 times 4 is 16. 4 times root 5 is plus 4 root 5. Negative root 5 times 4 is negative 4 root 5. And negative root 5 times positive root 5 is negative square root of 25. And the square root of 25 is 5, so it's just minus 5. When you multiply the square root of something by the same square root, it's just going to be that number that's on the inside. And the nice thing about conjugates is these middle terms should always cancel each other out. 16 minus 5 is 11. Unlike the last problem, there's nothing that all these coefficients have in common, so here is our answer. Another way you could write that one is negative 40 minus 10 root 5 over 11. It'd be the same thing. Instead of leaving the negative sign out front, we could distribute it to the terms in the top, or I could keep my numerators positive and have the negative sign go down to the denominator. That would be okay. The one thing you can't do, though, is you can't say that this negative sign will go to the numerator and denominator, because then all those negative signs would cancel out. You get back to a positive, and it wouldn't really be the same thing. So this is the one way we can't write it, so let me go ahead and fix it. I'll put the negative out front, and there's our answer. And then in problem number 50, we have x's on opposite sides of the equation, so let's get all the x's to the left. It could be to the right. I'm just choosing to go to the left again. Add 7 to both sides. So there is our first step. Next, I'm going to factor out the x again. X times 3 root 10 minus 2 equal to 13. Next step, divide both sides by that binomial. So x is going to be equal to 13 over 3 root 10 minus 2. Next, in order to rationalize the denominator, we're going to multiply by the conjugate, and that's 3 root 10 plus 2. So then in our numerator, we have 13 times 3 root 10, that is 39 root 10. 13 times 2, it's 26. So there's our new numerator with the radical in it, but that is okay. And then in the denominator, 3 root 10 times 3 root 10. When we multiply those, we multiply the outside numbers, so 3 times 3 is 9. Root 10 times root 10 is 10. 9 times 10 is 90. So 3 root 10 times 3 root 10 gives us 90. 3 root 10 times 2. Once again, we multiply the terms that we can. 3 and 2 are both outside of the radicals. 3 times 2 is 6. So this next term is going to be plus 6 root 10. Now the inside terms, negative 2 times 3 root 10 is negative 6 root 10. And then negative 2 times 2 is negative 4. Those are opposites. They're eliminating each other. 90 minus 4 is 86. And I'm looking for something that's going to go into all three of those terms. There isn't anything. So then this is the simplified answer. I hope that helps, and if you have more questions, I'll see you on the first day of school and we can go over some of those problems.